Hello, I'm Sam Felder, and this summer, during Google's Summer of Code, I worked on implementing a model of evolutionary biology called contextual geometric structures. Today I'll be going in depth about my project for GSoC, the INCF branch, and their interest in this topic, as well as how the project came to light. I'll then discuss how I went about making this project and finish by discussing future work that needs to be done. So like I said, my name is Sam Felder. I'm about to be a senior studying computer engineering at University of Illinois, Urbana-Champaign. I've had a couple internships in the past and wanted to do something that was a little different this summer. I heard about Google Summer of Code and thought it would be perfect because I've never previously worked on open source. As I was iterating through the list of opportunities within Google Summer of Code, I found INCF, which was at the intersection of neuroinformatics and biology. This has long been one of my interests outside of school, and I thought it would be really interesting to meld my professional interests along with my recreational ones. The paper my work is based on is Contextual Geometric Structures, Modeling the Fundamental Components of Cultural Behavior by Bradley Alicia. The idea behind the paper came about because the structural complexity of culture is difficult to characterize based on cultural beliefs or inherited ideas. Recent research in anthropology has allowed us to define structural models such as hot, cold, good, bad on different sides of the spectrum, but no one has yet really modeled evolution for such structures to occur. That is the point behind contextual geometric structures. The contextual geometric structure model allows us to simulate symbolic behaviors and see how these behaviors came to be. This approach allows us to approximate individual and group cultural practices while also in a fluctuating environment, simulating the real world. To do this, you can imagine an environment where the multiple cultures or things we were trying to model are within that environment. At the corners of the environment are these cultural structures, i.e. good or bad and hot or cold. I'll show you a simulation of this later so you can better visualize the process. So for my idea behind how to implement the contextual geometric structure model, I wanted to create an object-oriented design that would allow future engineers to easier work with the code base. I also wanted to make it a real-time simulation so you could run different simulations in real time and see what the data would output. Encompassing this would be multiple machine learning approaches where you could try different types of machine learning models and see which one fit your needs the best. Once this was all done, I created benchmark tests to understand the accuracy of both my code and what your needs were. Like I said, the code was designed with an object-oriented paradigm where I created a class that made all of the graphics for the visualization. And the idea was to have two levels of abstraction from the user. One would be the graphics factory, and the other being the different machine learning approaches. I originally wanted to implement all of these as libraries within the Blender file, and I'll get to that in a second. So this is the code flowchart. We start with input.txt, which I'll show you here. So this is the input file into the Blender script you'll be running. here we specify how many years you want the script to run. So for example, if you want to see evolution of a culture over 300 years, that's what we have here in this first line. In the second line are the tuples. Like I was saying earlier, archaeologists have previously defined structures that go from a continuum of hot and cold, and here we're trying to define more than just hot and cold. So in this case, rather than it being a two-sided kernel, it would be three, where we have hot, soft, and cold. For this specific run, I wanted to create 5 cultures and see how they reacted with each other. And that is what the third line is for. And then the fourth line is the initial population size, which you can scale down or up depending on your needs. I did this because the initial population size is incredibly important for the type of work you want the algorithm to do. The fifth line is if you want the program to show you a graph of the frequency of the words we'll be using through Google Ngrams. And the sixth line tells us what type of machine learning we'll be using. So on this line, we could either do KNN.py, which would be a kth nearest neighbor algorithmic approach, or genetic algorithm.py, which would be a specially tailored algorithm for use with this, with the CGS model. And then finally, the last line would be to customize how many years occur in each frame of the visual. So for example, you could make each frame have 1 year, 2 years, going all the way up to 20, if you want a more generalized visual. After you create your input.txt file to your specifications, you will run it. You could run it at the command line or through the Blender application, which you can see on the GitHub. From here, I would create data specific to what you asked for in the input.txt file. That's largely dependent on things like what type of algorithm you wanted, how much you wanted in your population. The 2 types of data set I created included, for the kth nearest neighbor algorithm, images of different rectangles that would be placed on a continuum. And for the genetic algorithm, a dictionary of words that we would pick from to start our initial population. And like I said, I did this with an object-oriented design that would keep everything encapsulated so that it allows for less user error. The graphics factory class that I created everything you see in the visual from the 5 cultures that I mentioned in the input.txt, the kernel that the cultures live in, and the tuples, which were, in our example, hot, soft, and cold. The real-time simulation, like I mentioned earlier, makes data based on what you want. And the original plan was to use libraries that I created to change the visualization. And the two machine learning implementations I created were a kth nearest neighbor approach and an evolutionary algorithm approach, or a genetic algorithm. So the kth nearest neighbor approach I made by creating a data set of 4 different shapes: circle, octagon, hexagon, and rectangle. And it would create images. From there, my KNN algorithm would predict what type of images these were, and it would place it on a continuum from rectangle to circle, or square to circle, and then it would predict images that the user gives for where on this continuum the new images would be placed. Then for the genetic algorithm I created again with an object-oriented approach, a number of individuals that was part of a population. And from there, these individuals being words, part of a bigger population you consider a dictionary. And from there, I specified maximal fitness for evolution, for evolutionary purposes. And I would view how many generations it would take for the children to get to maximal fitness. I also created benchmark tests that simulate the speed, that test the speed of the Blender file and everything that comes along with it, the accuracy of the genetic algorithm and the KNN algorithm, and also the standard deviation of both. Things that I would have liked to have done and blockers that occurred included integrating cultures in the Blender simulation with real-time data. The issue I had here was that Blender did not play nicely when I tried to import my own files, my own libraries that I've created. And because of that, I couldn't access data that I created within the Blender file. This created an issue where I would have to load the data after a single run rather than doing it in real time. And like I just mentioned, importing external files that I created throughout the summer as libraries into the Blender file, rather than having to run them internally through Blender with a script. This would allow for greater flexibility for the user as well as the programmer. That, along with creating compatibility with Windows, since I didn't have access to a Windows machine over the summer, I can't say that I'm sure it will be compatible with Windows, as well as extending the genetic algorithm that I created to higher dimensional representations of culture. What I mean by that is, as I mentioned, right now I create one word that is considered maximal fitness for the population. And rather than doing that, I create a population or a maximal fitness, not based on one word, but based on a number of attributes. Going back to our original example, you could take hot cold or hot soft cold. So defining a maximal point among those three rather than among just one or two of them. Thank you. That is all. I want to say thank you to INCF and Bradley Alicia for taking me on as a mentee. I had a great summer and really recommend Google Summer of Code to anyone looking at this video.
Well, thank you for the presentation and going through the project. So, do you have any more thoughts about the fitness function? What would you do, like, more generally? How do you feel about genetic algorithms? Do you think you understand it well enough now to apply it to different kinds of problems, or?
Yeah, definitely. Genetic algorithms was my favorite part of the summer. It was a new paradigm of looking at solving a problem, and I definitely think I have a much better understanding of it from before. And like you saw, I implemented my own. So yeah, I couldn't say enough. It was really interesting.
Yeah. And so the fitness function, you said there need to be improvements made, or so like what would you think would be like? How would you improve it if you didn't have technical constraints?
Yeah. So my first thought on improving the fitness function, as of right now, like I said, I have one word. So for example, hot, and my code optimizes to get to hot. So it mutates and each generation evolves to get to hot. But I'd rather it not be based on one word and be based on a set of attributes that each individual has that are, say, weighted. So for example, in the case of hot, soft, and cold, the maximal weight could be 1, and you can only get to that with a certain attribute being a certain number. And then, so I would give attributes to each of these individuals, and once they all added up to 1, you could say that that individual had a maximum fitness.